Okay, so in this video, let us try to prove the commutativity for rational numbers under the operations of addition, subtraction, multiplication, and division by using a single example. Now let's begin with addition. Now the test for commutativity is you take any two rational numbers. In this case, we are saying let a be one rational number. In this case, a is minus of 2 by 3 and b is 5 by 7. Now what we are doing is we are adding these two numbers, that is a plus b. So minus 2 by 3 plus 5 by 7, when we simplify this, gives us 1 by 21. That's what we get. And then what we do is we reverse the order of operation, that is we do b plus a. Let me just correct this over here. So this is actually b plus a. Okay, so now we are doing 5 by 7 plus of minus of 2 by 3, and when we simplify this by taking the LCM of the denominator and then multiplying the numerators as required to make the same denominator, we get the same number, 1 by 21. So this example we have taken for only any two rational numbers. You can try for some more rational numbers and you will find that it doesn't matter in which order you add those rational numbers, you'll always get the same result. And therefore we conclude that for any two or more rational numbers, a plus b equals b plus a. That is, even if you change the order of operation, the result will be same. And hence we say that rational numbers follow the commutativity under the operation of addition as is shown over here. Now let us look at subtraction, and in this case we will use the same number. So what we do is a is 2 by 3 and b is 5 by 4. So that's what we are doing. Now let's do a minus b. So a is 2 by 3 minus 5 by 4. Following the same principle that we look at it, we get minus of 7 by 12. Now if we do b minus a, which means 5 by 4 minus 2 by 3. Now please note, in this example both of the numbers that I have taken are positive, not taken a negative and a positive number. So this is just, that's the difference from the earlier example that we looked for when we were looking at addition. So when I do b minus a, we get, simplifying this, 5 by 4 minus 2 by 3, we get plus 7 by 12. Now you can see that a minus b is minus 7 by 12 and b minus a is plus 7 by 12, which means the sign is different, and therefore we have to tell that if we change the order of subtraction for two rational numbers, the results are not the same, and therefore we have concluded here that a minus b is not equal to b minus a. So we can conclude that the rational numbers do not follow commutativity under the operation of subtraction. Now let us look at the other two remaining operations, that is multiplication and division. So in multiplication what we will do is we'll just take two numbers and just multiply each other. So first we are doing a multiplied by b, and minus 7 by 3 is a and 1 by 2 is b. Again, multiply the numerators and the denominator separately and keep the sign. So we have minus 7 by 6 as a result, and then we change the order of operation, that is we do b by a. So that is 1 by 2 multiplied by minus 7 by 3, and when you simplify this you get minus 7 by 6. Now you can see that in this case we are getting a multiplied by b equals b multiplied by a, and you can try this for more rational numbers. You will find that this is always the case. When you multiply two or more than two rational numbers in any order, the result remains the same, and hence we say that the rational numbers follow the commutativity property under the operation of multiplication. Now let us look at the property of division, which is shown over here. So what we do in this case is take any two numbers like we discussed earlier. So we have a divided by b. So let's take minus 5 by 4 divided by 3 by 7. And as I taught you earlier, or as we discussed earlier, you can convert a division into a multiplication problem by just exchanging the numerators and denominators. So this thing here, becomes minus 5 by 4 multiplied by 7 by 3. You can see that I have changed the numerator and denominator. So when we solve this, we get minus 35 by 12, both multiplying the numerators and denominators. However, when we do b divided by a, so in this case now we have 3 by 7 divided by minus of 5 by 4. Again, you can do the same thing, convert this division into multiplication and change the numerator and denominator. Now remember, I have done 4 by minus of 5. It really doesn't matter whether your numerator, you have a negative either in the numerator or denominator. You can always put a negative sign in front. So this minus will go up in the result as it's shown over here. So 3 times 4 is minus 12 and 7 times 5 is minus 35. So we get minus 12 by 35 over here. Now what you can see is minus 35 by 12 is not equal to minus 12 by 35. Therefore, we can say that a divided by b is not equal to b divided by a for this case, and hence I can conclude that the rational numbers are not commutative under the operation of division. Now, this was kind of our discussion on how do we prove the commutativity for these different operations, the basic arithmetic operations for the rational numbers. The only thing to keep in mind when we try to prove this is just to find out a case where that particular property will not be satisfied. So for example, in division, we took any two numbers and we found out that when we try to do a divided by b and b divided by a, it's just not equal, and hence it is sufficient for us to tell that they are not commutative under the operation of division. Okay, so that was our discussion on proving commutativity for rational numbers.